Hello friends, today I came up with some important questions. They are really challenging questions. They are important for your St.xaviers entrance examinations as well as other different entrance examinations. Especially if you practice this question, you can solve different type of other questions. You may find this question a little bit difficult, but practice it. In an entrance examinations, different type of question will come, but after tackling these questions, they will be easy for you. Now let us see this question. In this question, we are given two markers m1 and m2. Markers are like 2 points, and there is one spherical ball. This one is spherical ball, and this one ball is at time 0, t is equal to 0, and it will reach up to marker m1 by traveling distance x at a time t1. And the marker, this ball reaches to the point m2 after traveling distance h plus x, in a time t2 at a point m2 or at a marker m2. Now we need to find the acceleration of the ball. Which expression represents the acceleration of the ball? For this question, I have collected this question from different source. For this question, most of the students fail to solve this question because of wrong supposition. Let us see this. If you simplify the figure, then we will get this. From t is equal to 0 to t is equal to 1, it is traveling distance x, and from t is equal to 0 to t is equal to t2, it is traveling to distance h plus x, and the time taken for the ball to reach from m1 to m2 is t2 minus t1. Now the firstly let us see this is the solution of this question in this method. See, the time taken for the height h is t2 minus t1, this t2 minus t1, and our formula is s is equal to ut plus half at square, and I have written h is s, and initial velocity u is 0, and a can be replaced by z, and t is equal to t. Now our t is t2 minus t1 for the distance h, and we will get answer g is equal to twice h t2 minus t1 whole square, which is in option choice C. But this is a wrong answer. This is not a right answer because of our supposition in this question. In this question, we suppose that u is equal to 0. Here we suppose that u is equal to 0. In fact, u cannot be 0 for the height t2 minus for the height h. When body comes at this point m1, it means that it has some certain velocity. So we cannot assume that for the height h initial velocity is 0, because 0 is here, zero velocity is here, 0 velocity is not here at this point. Because of that, this answer choice is wrong. Now if we see this, we can solve this question in this way. For the height x initial velocity is 0. So if we write s is equal to ut plus half at square, in that case, if we write s is equal to ut plus half at square, our u will be 0, and half is there, a is small g, and t is t1. T1 is time taken for this distance travel. Now for the second case, we need to assume the ball is at this point. We need to assume ball is at t is equal to 0. Again we need to assume ball is at t is equal to 0, and it is traveling a distance h plus x in the time t2. Because of that, we can write u is equal to 0 in the second case. Height will be h plus x, and time will be t2, and initial velocity will be 0, because our height is h plus x, means our object is at this point. Because of that, we will get our second expression. On subtracting this expression or substituting the value of x from first expression, we will get our h, and we can rearrange this h to get our correct answer. This is the correct answer, twice s by t2 square minus t1 square, which is in our option choice D. D is the correct answer for the question number first question. Now let us see this question. The relation between the resistance, length, area and resistivity is. we know that resistance of a wire is directly proportional to length and resistance of wire is inversely proportional to area. Resistance of wire is directly proportional to length and resistance of wire is inversely proportional to area. On arranging them, we will get resistance is equal to rho L by A. Here this rho is called resistivity. Here this rho is called resistivity, and resistivity is a proportionality constant, and the value of resistivity does not depend on original length or length of a wire and area of a wire. This is constant for a given substance. For example, copper has some resistivity, silver has some resistivity. On changing length, area of copper and silver, their resistivity won't change, it will remain same. Now if we see our option choice B contains this answer, so B is the right answer for the question number for this question. Now let us see this question. I have collected this question from different source, because of that this number is not synchronized here. What is the typical value of order of magnitude of resistivity of copper? Now we need to find the order of magnitude. Order means 10 to the power of 10 to the power value. Now if we see the resistivity table, here our copper is here in the second line. Because of that our answer will be option choice B, 10 to the power minus 8. The unit of resistivity is ohm meter. Unit of resistivity is ohm meter. On writing the unit of R is measured in ohm, L is in meter and A is in meter square. We will get our unit of resistivity, that is in ohm meter. And 1 by resistivity is called conductivity. 1 by resistivity is called conductivity. Because of that this is the value of resistivity and this is the value of conductivity. Now let us see this question. A copper wire is cylindrical and has radius r. What will be the resistance of the copper wire of twice the length and twice the diameter? If this is a copper wire, then length of the wire is this and cross section area is this. This is the cross section area, which is pi r square or pi d square by 4. Which is pi r square or pi d square by 4. Our standard formula to calculate resistance is R is equal to rho L by A, and I have replaced A by pi r square. Now in the second case, it is saying that length is twice and radius is also twice. Because of that I wrote here twice L and 2R. I wrote here twice L in the place of length, and in the place of R I wrote 2R square. On solving this, on comparing this first resistance and second resistance, we get our answer R dash is equal to R by 2, which is in option choice B. So option choice B is the correct answer for this question. Now let us see this question. This is also important question. In this question we are provided two copper wires X and Y. The volume of wire X and volume of wire Y are same. According to this question, they got same volume. Length of second wire is 4 times of the length of the first wire. Now our task is to find ratio of resistance of Y divided by resistance of X. Ratio of resistance of Y and X. For this, now let us see. This is our relation R is equal to rho L by A. I will do some modification in this. I will multiply by L in numerator and in denominator. If I multiply L on both sides, numerator and denominator, the denominator part will give us volume. Volume is equal to area into length. Volume is equal to area into length. So we will get our resistance R will be rho L square by V. Our resistance will be rho L square by V. Now Rx will be rho L square by V, and Ry will be 4 times L square. In the place of L I have to write 4 times of L, and volume is same. According to question, volume is same. Now I got 16 rho, this is in fact this rho, 16 rho L square by V. On dividing this Ry by Rx, we will get 16. That 16 is in our option choice. D. Because of that our answer is D for the question number for this question. Now let us see this question. Iron wire has length 8 meter and diameter 5 millimeter. The same iron wire and its resistance is R, and the second iron wire, second is also iron wire, Second is also iron wire, and the second iron wire has a length 2 meter and diameter 1 meter. What is the resistance of second wire? Our formula is R is equal to rho L by A. R is the first resistance of first wire. Rho is constant, L is given 8 meter, and by using this formula, this 0.5, by using diameter is 0.5, pi d square by 4, we get our R. Now our second R will be R dash, and for R dash also we can use, for R dash also we can use same rho. R dash is equal to same rho, and length will be 2, and area will be calculated by using pi d square by 4. On calculating this and on dividing or on comparing, we will get our answer will be R by 16 for this question. Or we can calculate rho of first wire and rho of second wire. As rho and rho are same, we can keep resistance of first wire as R and resistance of second wire as R1. In that way also we can find R1 is equal to R by 16. Now let us see another question. This question we already solved. In this question, see, this is also easy question, but it can be confusing for you. See, this is the resistor of resistance R, and 2 resistors are in parallel combination here, and 3 resistors are in parallel combination here, and this 1, this 2, and this 3 whole combination are in series combination with each other. If we solve this, we will get R by 2, because resistance of all resistor is R. And if we solve this, we will get, if we solve the third part, we will get R by 3, because in parallel combination the resultant resistance is 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now first resistance is R by 2 and R by 3 are in series combination. Because of that we can add them, and the final result of them is 66. On solving this, R plus R by 2 plus R by 3 is equal to 66. We will get our answer, and our answer for this question will be 36. Simply we add R by 2 and R by 3. Because of parallel combination we will get R by 2. Because of parallel combination here we will get R by 3, and their sum will be 66, and we will get our R. So option choice D is the correct answer. Now let us see this question. This is also important for your entrance. In this question we need to know what is electric field lines. Electric field lines are imaginary lines. They starts from positive charge and they ends in negative charge. They are not this type of circular. Because of that, option choice C and D are wrong. For negative point charge, this is our answer. If you can see my one video on electric line force, in that I explain this with the example of some potato, and by using potato and by using some lemon, I describe the whole electric field lines and other different questions. This is for negative charge. It is going inward towards negative charge, and this is for positive charge. If I write here positive charge, if I write positive charge here, then this will be the diagram for positive charge. For this question, it is asking for isolated negative point charge. Because of that, option choice B is the correct answer for this question. It cannot be circular. It cannot be like this. This is for positive, this is for negative. Now let us see this question. This is also easy one. Here is one square, and here is positive charge, here is negative charge, here is negative charge, here is positive charge. If positive and negative charge are separated by some certain distance, then they will make these field lines. It will start from positive and it will go towards negative. It will start from positive and it go towards negative. It will start from positive and it go towards negative, as shown in figure. Now if we see this diagram, X is electron. X is clearly electron. For electron, the electric force is towards positive charge. I am again repeating this. For electron, the electric force is towards positive charge. So our answer cannot be C and D. Our answer cannot be C and D. And in electric field lines, the tangent give the direction of electric force. So A and B can be our answer, but A is not tangent. Only the tangent in this figure is B. Because of that, our answer choice B is the correct answer for this question. Electric field line starts from positive. Electric field line ends in or goes towards negative, and electron always show its force. Electron always experience its force towards positive plate, and the direction is always tangent. Because of that, our answer is B. Now let us see this question. In this question, what is a possible moment of electron? See, if this is one plate, this is another plate, and field is going like this down, then upper plate must be positive, lower plate must be negative. We know this because electric field starts from positive and it goes towards negative. This plate is negative, this plate is negative, this plate is positive. Now if this plate is positive and this plate is negative, we know electron are negative charge by their nature. Charge of electron are negative, so it must be either A or B. C and D cannot be our answer, because electron are negative charge, they should move towards positive plate, and path of electron is not a straight line, it is a curved line. A curved line toward positive plate is A. Because of that option choice A is the correct answer for the question, for this question. Now let us see another question. In this question, this is positive plate, this is negative plate, and the potential difference is V here, D is the distance. We know our formula to calculate electric field strength, E is equal to voltage divided by distance between the plate. E is equal to V by D. E is equal to electric field strength, V is the potential difference, D is the distance between this plate. Now among this option choice, which graph represents E and D for constant V? If V is constant, E is inversely proportional to, if V is constant, E is inversely proportional to D. E is inversely proportional to D. And this type of nature is shown in option choice A. This type of nature is shown in option choice A. Because of that, option choice A is the correct answer for this question. Now let us see this question. A filament lamp has resistance 180 ohm. A filament lamp has resistance R is equal to 180 ohm, and the current is 500 milliampere. I is equal to 500 milliampere. We know that milli can be converted into ampere by multiplying 10 to the power minus 3. So this is our resistance, this is our current. Now we need to find the power. The formula to calculate power is P is equal to I into V. VIP. P is equal to I into V, but our V is not here, so we can use Ohm's law. V is equal to IR. By using V is equal to IR, we can use our formula I square R. Now on doing I square R, this is our I, this is our R. On converting this into proper unit, we will get our answer. That answer will be option choice A, 45 watt. 45 watt is the answer for the question, for this question. Now let us see another question. In this question it is written that what is 1 volt? 1 volt means work done to move a point charge from one point to another point. So if I write V, I can write V is work done per unit charge, W by Q. V is work done per unit charge. It means that if 1 joule of work is done by 1 coulomb, then it is called 1 volt. Because of that, our option choice B is the correct answer. 1 joule per coulomb. 1 joule per coulomb is in option choice B. Now let us see this question. The diagram shows this graph. This is y-axis, this is x-axis, this is a line. This line means the variable we keep in x and y-axis should be directly proportional with each other. They should possess a directly proportionality relation with each other. Now this is so important question for you, for your higher level as well. Now you need to find those variables which can be kept in x and y-axis and they can follow this relation directly proportionality. Now let us see our first option choice, current and potential difference. Yes, if I keep current over here and voltage over here, then I is directly proportional to V or V is directly proportional to I. This is the Ohm's law. This is the Ohm's law. Because of that, option choice A and option choice D both are correct. Because I is also directly proportional to V, I can keep I over here and V over here, and I can reverse this as well. I can keep V over here and I over here. In that case also I will get a straight line. So option choice A and D cannot be answered for this question, because in this question we need to see those variables which cannot be kept in this relation. Resistance and length. We know that resistance is directly proportional to length. Because of that, B is also correct, which is not our option choice, because we need to find which is not correct relation, which is not correct variable. Now if you see B, if you see C is the correct answer for this question. Resistance and temperature do not follow the directly proportionality relation. Because of that, they cannot be kept in this question. So option choice C is the correct answer. They cannot be represented by this graph. Now let us see this question. In this question, electric kettle is the power of electric kettle is 3.10 kilowatt and the supply is 240 volt. It means power is equal to 3100 watt. I have converted kilo into watt, and V is equal to 240. Now we need to find current, and our famous relation to find the current in this case is P is equal to I into V. P is equal to I into V. P is also given, V is also given. So we'll get 12.9 is our current, and we know our V, we know our I. Now we have another relation, V is equal to IR. On doing V is equal to IR, we will get our R. R will be 18.6 or near value of 18.6. So option choice C is the correct answer for the question number 33. Now let us see this question. This is also important question for you. Here is R, here is 2R, and here is 3R. They are in parallel combination. The basic feature of parallel combination is voltage across R, voltage across 2R, and voltage across 3R must be same. If voltage in R is some 5 volt and voltage in 2R also 5 volt, voltage in 3R it will be also 5 volt because they are in parallel combination. Now among this option choice, we need to find the current in R, 2R, and 3R. In this column, in this line, all current are I, all are same. We can take reference from this, and our R is R. Because of that, potential in this R is IR. P is equal to IR. Now anyhow, we need to get this same potential IR in 2R also, in 3R also. In 2R already 2R is there. If I multiply that 2R with 1 by 2I, then we will get IR. 1 by 2I into 2R means IR. Because of that, this 1 by 2I is correct expression for second column. Now if I see third column or third line, here is 3R. So in order to get IR, I need to multiply this expression by 1 by 3I. Because this contain IR means this should be also IR, this should be also IR. Because of that, our option choice B is correct answer for this. Because on multiplying I with R, I will get IR. 1 by 2I into 2R also gives IR. 1 by 3I into 3R also gives IR. Because of that, option choice B is the correct answer for this question. Now let us see another question. This is so important and last question for you. I will explain this question and I will leave this question as a homework for you, and then I will be explaining the answer of this question. A boy is throwing a ball upward and it is rising. It rises to a maximum height where it momentarily at rest, means for a fraction of second, for a certain time it is at rest and it is falling back to his hand. Now which row gives the acceleration of a ball at various stages of its motion? We need to take vertically upward direction as a positive direction, and we need to ignore the air resistance. Now we need to find the answer among A, B, C. We need to generalize. We need to know the idea about the direction of acceleration. Thank you very much.